Okay, and in this video I'm going to talk about the cases for nonlinear static procedure related to 2D modeling, if it is allowed or not, as I said, according to ASCE 41. And here under section we're talking about nonlinear static procedure, which is related to pushover analysis, for example, if you are going to use it. So under this section 7.4.3.2.6, analysis of mathematical models for NSP, which is nonlinear static procedure, they said that separate mathematical models representing the framing along two orthogonal axes of the building shall be developed for two-dimensional analysis. This means that two-dimensional analysis is allowed and it is separate. You can use separate analyses. So you can use, for example, these two main resisting, or the main resisting framing system in X direction, for example, and then in Y direction you can use the other two perpendicular, which are orthogonal to the first direction, and they are separate, as we said here. It is separate, both of them, they are separate. Okay. And another alternative, it is also always it is the most accurate way of modeling, which is the 3D modeling. Okay, a mathematical model representing the framing along two orthogonal axes of the building shall be developed for three-dimensional analysis. So this is the case for 3D dimensional analysis. It is always welcomed, of course, but we are talking about when and whether or not it is allowed for using the 2D analysis, and we found that it is allowed here for nonlinear static procedure under ASCE 41. Okay, the effects of torsion shall be evaluated in accordance to section 7232. And independent analysis, this is an important comment here. Independent analysis along each of two orthogonal principal axes of the building shall be permitted unless concurrent evaluation of multi-direction effects is required by this section, section 7.2.5. What is the meaning of this? Sometimes we have, for example, like corner column, and in this corner column we need to get the stresses on it based on two directions. So there is a concurrent evaluation or stresses coming from two directions. So we cannot use one dimensional here or independent analysis. Okay. So in this case, if it's permitted, it's okay. If not, then unless there is a concurrent evaluation of multi-directional effects is required by this section. Okay. So we can, based on this section, we can tell whether or not it is allowed for a certain or a particular element to use separate two-dimensional analysis or not. If not, according to this section, then, for example, for this column, we need to get the stresses coming from two perpendicular direction, then we need to use 3D, for example, or what we call it, the multi-directional effects, Okay, so this is for NSP. At the end, we're going to end up with an NDP, which is nonlinear dynamic procedure, based on ASCE 41. Under this section, they are telling that modeling and analysis consideration for nonlinear dynamic procedure, general requirements for NDP, the modeling and analysis requirements specified in section 7.4.3.2 for the NSP, which already we have explained before in the previous slide, shall apply to the NDP. So there is no difference here. It is allowed also to use 2D or 3D, and if there is concurrent evaluation based on multi-directional effects, then you need to take into consideration this by making 3D, and if not, then 2D is allowed for your case. You can take 2D for each main lateral resisting system, and you can continue for this. Excluding considerations of control node and target displacements, this is something specific to NSP and NDP, we are going to talk about it later, and it's not the scope of this video. But anyway, now we have a good understanding of when and when not to use 2D analysis. Remember, we have some precautions, especially related to the 2D analysis when there is some specific issues that we want to apply 3D. Always 3D is most welcomed, as we have said, but sometimes we need to consider some sections that is related to concurrent or multidirectional evaluation. Then in this case we need to be careful and respect the item itself or the section itself. Okay, thank you, and see you in the next video.